Hey guys, Mrs. Saller here. We're actually going to be reviewing the things that we talked about on the second day of 7.3 today, which is still volumes using cross sections, but just for those of you that haven't been here, and also just to go over one of the harder homework questions that's a little bit new as well. I wanted to spend some time putting this video together for you. So we're still doing section 7.3, which is all about volumes using cross sections. And we're going to just look at two more examples today that are a little bit different. And one of those will be one of your homework questions. So if you happen to look at this video, you'll get one of your homework questions taken care of as well. Alright, so let's take a look at this example, which I know I started in period 7-8 today, but I didn't finish and I didn't even get to in period 10. So let's take a look at this example, which in this case we have a solid that lies between planes perpendicular to the y-axis, and this is where it's different than what we were doing yesterday. Is everything we did yesterday was perpendicular to the x-axis, so it's a little bit different. Perpendicular y-axis instead. At y equals -2 and y equals 1. The cross sections that we're going to have here are of course perpendicular to the y-axis, and our squares with sides running from the graphs of x equals y squared plus 2 and x equals y minus, or 1 minus y squared. Okay, so we want to find the volume of the solid that's created by all these facts here. Okay, so we have a base that's going to be determined by running the sides between y squared plus 2 and 1 minus y squared from -2 to y equals 1, with the cross sections being squared with the sides running from x, those two graphs, the x equals y squared plus 2 and the x equals 1 minus y squared. So as usual, let's take a look at the graph. Now I'm thinking in this case that we actually want to graph these the way we normally do with sideways. Okay, so mark your axes, we're going to turn the sheet so it's pointing that way up, and graph those two graphs. So let's start with the y squared plus 2, so you'd be going up 2 and opening upwards sideways. Okay, so here's the graph of x equals y squared plus 2. And the other graph is the graph of 1 minus y squared. So we're going to 1 and we're opening downwards like that. Now obviously these don't intersect, and that's fine because they did give us some boundaries to work with here. They said only look between y equals -2 and y equals 1. So like that. Okay, now this is our base region. Okay, this is our no base region, so it kind of looks like an hourglass. And what we're going to do here is we're going to make cross sections that run perpendicular to the y-axis. This is where it gets a little kooky. Right, perpendicular y-axis running between those two. So we're going to have squares kind of popping up out of the picture like this. Okay, so kind of imagine that. As you go down, they're going to get bigger, and they're popping out of the paper at you. So we need to figure out what the area of one of those cross sections is before the calculus pops in. Now, it looks like when we're doing a problem like this that length there of one of those sides is going to be the top function we're looking at sideways. The top function is the y squared plus 2 minus the bottom function, which is the 1 minus y squared. And one of the big lessons today was that anytime you're perpendicular to the y-axis, all of your stuff should be with y's. If you're perpendicular to the x-axis, everything should be in terms of x. Alright, now when we subtract those, we get 2y squared plus 1, and that's going to be the sides of our square. Okay, so top function minus bottom function, when you're looking at it from the side, is the y squared plus 2 minus the 1 minus y squared. That gives us the length of the side. So we're setting up our area formula for the cross section. It's going to be with respect to y, and it's just going to be, well, 2y squared plus 1 times 2y squared plus 1. I would go ahead and multiply that out, so it's 4y to the 4th plus 4y squared plus 1 unifoil, and that is our area of one cross section. So to get the volume, we're going to take the integral of that, so of the 4y to the 4th plus 4y squared plus 1 with respect to y. Now because we're all with y's, our limits are going to be y values, so we started at -2 below and moved up to 1, so -2 to 1 are upper and lower limits. So now let's take the antiderivative with respect to y, so this will be 4/5 y to the 5th plus 4/3 y cubed plus y, and we're going to evaluate that from -2 to 1. So plug in the 1, you get 4/5 plus 4/3 plus 1 minus when you plug in negative 2, you're going to get, let's see, negative 32 times 4 is going to be negative 128 over 5. Minus here, we're going to get 8 times 4, so negative 32 over 3, and then minus 2 there at the end. Again, save the common denominators to the end. Add like terms, you get 4 plus 128, so 132 over 5. Plus, that guy will be 36 over 3. Well, that's nice. Okay, we'll deal with that in a second. And then plus the 3, 1 plus 2. So we actually end up with 132 over 5, plus this is 12. So we have 12 plus 5, which is 15. Get a common denominator, and you have 132 over 5 plus 75 over 5, which turns out to be 207. So I can do arithmetic, 207 over 5. And we have now just found the area, the volume of that goofy shape that will occur when you take that kind of hourglass shape and stick squares as cross sections on top of it. Alright, so now that you've seen one like that, let's take a look at a slightly different one that you guys had to do in your homework tonight, which is number 42. Okay, and number 42, they give you this great picture, and it says the base of the salad is the disk x squared plus y squared is 1, which we've done that picture a couple times now, so it's just our circle with a radius of 1. Okay, so this is the base of our salad. This is where we're going to stack our shapes out onto. The cross sections by planes perpendicular to the y-axis, so again we're on the y-axis again, are isosceles right triangles with one leg in the disk. Okay, now the disk, or the cross sections, are going to have legs on the perpendicular to the y-axis. So you're going to have the leg. The hypotenuse is actually going to be popping out like that at you. Okay, so you kind of picture what's happening. It should be really pointed as it pops up at you. Okay, and you're going to have obviously an infinite number of those from top to bottom. And again, the picture in the book is much, 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 much better. You might want to look at that one. So it's going to be kind of like, I don't know, it's kind of hard to picture this one. It's going to actually be kind of like a lopsided cone when you're done with it. Okay, it should look kind of like a lopsided cone. Alright, now we need to figure out what the area of that cross section is. So let's go ahead and try to figure that out. Now again, we're perpendicular to the y-axis. So really, you're looking at it sideways. This piece is x, and this piece is x. And we do know what x equals to, because we know x squared plus y squared is 1. So x squared is equal to 1 minus y squared. So x is equal to root 1 minus y squared. And so one of these sides is 2 of those, so 2 root 1 minus y squared. And since this is a leg, that'll be congruent to that. And we've just found the two sides, or the two legs, of our isosceles right triangle. So this area, with respect to y, will be 1/2 base is the 2 root 1 minus y squared, times the height is the same thing, so it's just another congruent leg. Multiply that, well this is actually going to turn out to be just 2 times 1 minus y squared, and as usual, we get something really, really nice as our area. Alright, so when we set up our volume, we're going to be going from, well, we have our integral of the cross section. Now make sure you're using y values. We're going from y is negative 1 to y is 1. And now you can take the antiderivative. Alright, so when you take the antiderivative, you get 2y minus 2/3 y cubed, and we're going to evaluate that from 1 to negative 1. So when you plug 1 in, you get 2 minus 2/3. Minus when you plug negative 1 in, you get negative 2 plus 2/3, because the double negative. So you end up with 4 minus 4/3, which when you get a common denominator, add those, you get a very nice number, you get 8/3. Alright, so now I've done two examples with perpendicular y-axis, which really, guys, all perpendicular to the y-axis is you're going to have integrals and areas of cross sections with respect to y. If you're perpendicularly x-axis, you should have everything in terms of x. Hopefully that gets you guys a good head start on tonight's homework, and also is helping you feel more comfortable with this cross-sectional stuff, because tomorrow we're going to be actually doing something different with volumes. We're not going to be doing cross sections, we're going to be doing something completely different. So hopefully you're getting a handle on this. Please drop by if you have any questions, and thanks, and have a great night, guys.